Assalamualaikum and good evening everyone. We are from group 3 and my name is Nurul Aiman binti Azman with matrix number BC253384. Next.
Hi and Assalamualaikum everyone. My name is Nur Iza Anisa binti Majindi and my matrix number is BC250665.
Hi and Assalamualaikum everyone. My name is Nurul Nazatul Shima binti Abdul Khair and my matrix number is BC253230.
Hello everyone, my name is Divya Kadilisan and my matrix number is BC251139. Next.
Hi, my name is Siti Nadia Idana binti Halmi. My matrix number is BC252078.
First, the function is, this is the function which is x to the power of 4 plus 2x cubed minus 3x squared minus 4x plus 4. The first thing that we need to find is the critical number of fx. So the first thing that we have to do is to differentiate the fx, and this is the value that we get after we differentiate it. So next, we have to equal the first derivative that we get to 0 to find the critical number. So the critical number that we get is these three value, -2, -1/2 and 1. So next, we need to find the point of which fx has a relative extremum. So the first thing that we have to do is to do the interval table, where the interval notation we refer to the critical number that we get before. So for the first row, we get for the value less than -2, the derivative is negative, so the function is decreasing. For the value between -2 to -1/2, we get the derivative is positive, so the function is increasing. For the value between the -1/2 to 1, we get the function, the derivative is negative, so the function is decreasing. And lastly, for value more than 1, we get the derivative positive, so the function is increasing. So the graph will be like this: decreasing, increasing, decreasing, and increasing. So from that, we get that at the x equal to -2, it is relative minimum. X equal to -1/2, it is relative maximum, and at x equal to 1, we get the relative minimum. So next, we have to find the coordinate. So to find the coordinate, the y, we need to substitute the x value into the function, the first function here. So when we substitute the value of x equal to -2, we get y equal to 0. So when we substitute the value of -1/2, we get y equal to 81/16, and when we substitute the value 1, we get y equal to 0. So the relative minimum is at -1, 0, and also at 1, 0. For the relative maximum, this is the coordinate, -1/2, 81/16. So next, we need to find the interval on which fx is increasing or decreasing. For this, we just do the same table as above that we have done at here, and we get that the graph is increasing on here and decreasing on here, just as I mentioned before. Next, to find the concavity. So to find the concavity, the first thing that we have to do is to find the second derivative. So this is the value after we simplified it. So next, we have to equal the function that we get to 0. So this is the value of x. We get the two value. So next, we have to do the interval table. So this is the table, same just like before, but we replace the first derivative with the second one, and here we'll put the concavity. So we can look at the first row. we get the derivative positive, so it is concave upward. When the value is less than 0 for the derivative, we get it concave downward. And lastly, we get it the derivative positive, so it is a concave upward. So from that, we get that concave upward on this and this for the x value. And here is on when the graph is concave downward like this, so upward is like this. So this is the point of inflection that we get from the table. So we need to find the coordinate. So to find the coordinate, we have to substitute the value of the x that we get into the function, the first fx. So from that, we get the y value is 9/4 for both value of the inflection point. So this is the coordinate of the inflection point.
Okay, so now let's solve how to plot a graph using the polynomial function given using GeoGebra. So first of all, we have to insert the polynomial function, which is x to the power of 4 plus 2x cubed minus 3x squared minus 4x plus 4. After that, we have to find the extremum or the critical points. So when we tap enter, we got 3 critical points, which are A, minus 2, 0. This is the relative minimum. Then B, negative 0.5, 5.0625 is the relative maximum. And the last one is C, the relative minimum. Okay, and then we have to find the inflection point. What is inflection point? Inflection point is a point of a curve at which a change in the direction of curvature occurs. Okay. So we got 2 inflection points, which is D and E. And the last one, the y-intercept at 0 and 4. X-intercept negative 2, 0 and 1, 0. That's all from my part. Thank you.
For question number 2, they said two parallel sides, which is x, are being lengthened at the rate of 2 inches per second. So we know that the x dt is equals to 2. And also we know that the constant area A is equals to 50 inch square. So first we have to draw a diagram showing a rectangle with side of x and the width as y. So we have two given information, which is the dx dt value, this, and the area value. So from the area value, we can substitute the area formula, which is side times width, which is xy equals to 50 inch square, and then we make y as the subject, so we will get this equation. So the question asks us to find what is the rate of change of the perimeter. So this means what is the dp dt value when the increasing side, which is x. So what is the dp dt value when x equals to 5 and x equals to 10? So first we have to find the dp dt equation. To find it, we can use the perimeter formula, which is 2x plus y. first we have to differentiate P in terms of T, and we will get this equation. So we just have to substitute the dx dt value and dy dt value. So just now from the question, we already have the dx dt value, but dy dt value we have to find. But don't worry, we have the y equation. So what we have to do is we have to differentiate y in terms of t, and we will get this equation. So we just have to substitute all the dx dt value and dy dt value in this equation. So after substituting, we will get this equation, which is dp dt equals to 4 minus 200 over x squared. So the first question asks what is the dp dt value when x is equals to 5. We just substitute the 5 in x. So for the first question, we get negative 4 inches per second. And for part B, what is the dp dt value when x is equals to 10? The final answer is 2 inches per second. Now let's move on to the part C. What are the dimensions when the perimeter ceases to decrease? The statement when perimeter ceases to decrease means dp dt is equals to 0. So we already have found the dp dt equation in the previous calculation. So we just substitute the dp dt is equals to 0. So we just have to find the x value. So the final answer is 5 square root 2. So we have to write the perimeter stops decreasing when x equals to 5 square root 2, or also we can write in the decimal form, which is 7.07 inches. So that's all from me, and let's move on to the next part.
Hi. So now I'm going to explain on question 3. Can you guys see the slide?
Yes.
Okay. For question 3, it states that the total cost of producing X radio sets per day is the question given, and the price per set at which they may be sold is RM, the question given. And for question A, what should be the daily output to obtain maximum total profit? So, firstly, it is given that the question for total cost of X radio sets per day is Tx equal to 1 over 4 x squared plus 35x plus 25. And for price per set, which I put the answer as Px, is 50 minus 1 over 2x. So now we have to calculate the total price for X sets radio, which I put it as Rx. X is for the total number of radio and multiply with the price per set. Then we get the total price for X sets radio, which is 50x minus 1 over 2x squared. And then we search for the total profit, which I put it as fx equal to Rx divide Rx subtract with Tx, which is Rx is for the total price for X sets radio, and you subtract with the total cost for X radio set per day. Then we get the total profit, which is negative 3 over 4x squared plus 15x minus 25. And then we calculate for the first derivative to search for the critical points, which I got x equal to 10. Then we use the second derivative to determine whether it is maximum or minimum. And from the critical point, I get the value for second derivative is negative 3 over 2, which indicates it is less than 0. So it is maximum. So the daily output to obtain maximum total profit is 10 radio sets. And then for question B, first we have for question B is to show that the cost of producing a set is relative minimum at that output. Which is, firstly, we have to for the cost of producing radio per set, which I put it as Tx, and then we take the Tx here which is total cost x radio per set state and divide it by x. And then we got 1 over 4x here, 1 over 4x plus 35 plus 25 over x. And then we search for the first derivative, which we got 1 over 4 minus 25 over x squared. And then from here, we can search for the critical point. And I get 10. And then we use the second derivative to determine whether the value is minimum or maximum. And when we substitute x with 10, we got 1 over 20, which is greater than 0. So it is minimum. So the minimum output is x equal to 10. So it is shown that the cost of producing a set of relative minimum at the output. That's all from me. Now I'm going to pass for the next person to explain.
Alright, next moving on to equation 4. Evaluate each of the following limits using L'Hopital rules. So in the first equations, limit sin 3x over 4x, x approaches 0. So the first step is we need to substitute 0 into the x. So when we substitute 0 into the x, we will get 0 over 0, which is one of the indeterminate forms here. So when we get indeterminate form, we need to use L'Hopital rules, which is the first step is we need to differentiate it. So when we differentiate sin 3x, we will get cos 3x, and then we need to differentiate the 3x, 3. That's why it becomes 3 cos 3x. For the denominator, 4x, we will get 4. So we can continue to proceed to substitute 0, this 0, into the x, 0. So we get 3 cos 3, 0 over 4, and then the final answer is 3 over 4. So the second question is limit 3 exponent power of 2n over 4n squared and approaches infinity. So the first step is we need to substitute n with infinity. So as n goes to the infinity, the exponential term will become extremely large. So the numerator will be 10 to infinity. The denominator for n squared also grow without bounds. So it's also 10 to the infinity. And then the expression that we get is infinity over infinity, which is we know that one of the indeterminate form. So when we get indeterminate form, we will need use the L'Hopital rules, which is we need to differentiate this function. So when we differentiate 3 exponent power of 2n, the power of 2n, we differentiate it, we will get 2, and then 3 times 2, we will get 6. So the numerator will become 6 exponent power of 2n. The denominator also we need to differentiate it. It will become 8n. So the next step is we need to differentiate for the second time, which is second derivative, because when we continue to proceed with substitute n with the infinity, we will get the same answer, which is indeterminate form. So that's why we need to do the second derivative. So we need to differentiate the numerator 6 exponent power of 2n, and then the power 2n become 2, and then we times 6 times 2. We get 12 exponent power of 2n, and then n, we will get n. And then 12 over 8, we can simplify it, become 3 over 2. Like here. And then we can continue with substitute n with infinity. But the exponential term also become extremely large, so that's why it's become infinity. So the final answer for this equation is infinity. That's all from me. Thank you.
So let's move on to the last two questions. For the third question, the question states that limit x squared ln x as x approaches 0 from the right. We can change this form into this form, ln x over 1 over x squared. To substitute 0 from the right into x, we got negative infinity over infinity. This already in determinate form, so we can proceed to use L'Hopital's rule. First step, we have to differentiate the numerator and denominator. When we differentiate ln x, we got 1 over x, and when we differentiate 1 over x squared, we got negative 2 over x cubed. We can write into this form to make it easier. 1 times negative x cubed, we got negative x cubed, and x times 2, we got 2x. So x cubed over x, we can cancel off to be negative x squared over 2. Substitute 0 from the right into x, we got 0. And in conclusion, limit x squared ln x as x approaches 0 from the right, we got 0. Okay, for the last question, limit n exponent to the power of 2n as n approaches to the infinity. Okay, when we substitute infinity into n, we got infinity times infinity, which is not in determinate form. So infinity times infinity, we get infinity. To conclude, L'Hopital rule is not needed since the limit is not in an indeterminate form.
Thank you everyone. Bye.